Hi everyone and welcome back. So far, we have seen how AI understands individual words and documents. But what if we need AI to understand sequences like sentences, speech, or even time-based data? So that's where RNN come into picture, right? So let's look at these two sentences which are present over here. She only eats pizza. And then we have a second sentence, only she eats pizza, right? Now, the words that you see inside these sentences are actually the same, but the meaning that they convey are very different, right? Now, how does an AI understands the word order, and how does it understand that the word, changing the word order itself changes the whole meaning of the sentence, right? Now, this is where the Word2Vec and other models were actually failing, right? And that's where systems like RNNs or models like RNNs were formed. So the RNNs are designed to process sequence of data like text, speech, and time series information, right? Instead of just processing individual words, RNN remembers the previous word as they are read to the next one, right? And RNN can understand not only the meaning, but also the sequence in which it is said, right? So for example, she only eats pizza and only she eats pizza will have entire different meaning, and it will understand that. Let me give you another example where if an AI reads something like I am feeling, it can then predict the next word might either be happy or sad, right? And unlike the Word2Vec, which treats word in isolated format, RNN considers past word while making its prediction. So it will consider I am feeling, and then it will try to predict happy or sad, right? And this is what makes RNN great for chatbots, speech recognition, and translations. Now, how exactly does an RNN work? Again, we won't be going into the details of the model architecture, but we'll try to understand at a high level on how exactly does the RNN model work, right? So here's the step-by-step process. First, the AI reads the first word, creates a small memory out of it, and after creating the memory, it will read the second word, it will update the memory for both the words, right? And then finally, it reads the third word, and then the memory keeps on growing. So I'll give you an example over here to make it more clear. Given the sentence, the cat sat on a mat, right? Now, the AI will remember the previous word and then try to predict the word mat instead of just random words. So RNNs are designed to carry context forward as they are needed. Now, of course, RNNs were not perfect and they had their own problems, their own drawbacks. The number one or the biggest problem was the vanishing gradient problem, or to be in simple terms, forgetfulness. So if a sentence is very long, what happens is the RNN tends to remember the first few words, and then when the sentence gets very long, the RNN forgets the first words. So the AI might not be able to remember who was the subject of the sentence or what was the sentence talking about at the time when it reaches the end. So similar kind of thing. And the second thing, the problem is with struggles with long sentences. What happens is RNN works well with short sentences, but it fails when you have a longer paragraph. I'll give you an example. The boy who lived in a small village near the mountains and loved to paint suddenly disappeared. The AI might actually forget the word disappeared because the subject was too far back, right? And this is why the RNN were later improved by LSTMs and GRUs, which we will study in the next lecture. So stay tuned and share it with someone who might love it.